This is for your talk methods. It's the Tech Masterclass question 26F. And like in all questions right at the end, or lots of questions right at the end, they're giving you lots of hints from what they previously stated. So we know from the previous question that this here tells us that the x component of the stationary point is at a half, and this is plus a half, therefore that's going to be at a half and a half, and everywhere where the stationary point is on the line y equals x, when this gets reflected, we'll end up with having 3 intersection points. So in this question here, find a relationship. There are lots of relationships. We only have to find one. A relationship between R and S where this will always have 3 intersection points. Well, it's always going to have 3 intersection points if the stationary point is on the line y equals x. And that's going to happen when the x component of the stationary point and the y component of the stationary point are at the same point. So examples would be minus 3x minus 1 cubed plus 1/3 and minus 4x minus 1 cubed plus 1/4. Just to double check that, if I this is the one I'm looking at here, so if I go analysis, graphing, memory, initial, okay, and we graph that, then we do analysis, sketch, the inverse, and we zoom around that, I'm going to have 3 intersection points. Beautiful. If I change this to 3 and change that to 3, and I pick this up now and I drag and drop it, and analysis, gsolve, sketch, inverse, obviously I'm going to have 3. If I change this to 5 and I change that to 1/5 and xe, and I drag and drop, and analysis, gsolve, sketch, inverse, and we've got a similar thing happening. And we'll always have it that we'll get 3 intersection points when the point of inflection is going to be on the line y equals x. So the relationship between R and S is if this is minus Rx minus 1/3 plus S, then S has to equal 1 on R, or R has to equal 1 on S. So if R is 3, S is 1/3, when R is 5, S is 1/5.